Example number 3. So now, out of 17 students, we have the scores. So now I'm looking at this frequency table. I would plug the frequencies. I would have to plug these scores into my calculator. Pause the video and take a moment to do that now. When I did this, I found the question asked me to find my population standard deviation. But I know that it's usually, well, I'm going to need to find the mean eventually too. So I'm going to write down my x bar. I found that equal to 157. And I found my population standard deviation. So remember, population standard deviation is going to be our sigma on our calculators. So I'm looking at sigma sub x is going to be equal to 16.2299, which equals, I'm rounding here to the nearest tenth, it's going to equal 16.2. So, similar to the last question, how many of the scores fall within one standard deviation of the mean? So what I would have to do is I would have to subtract my standard deviation from my mean to find out how many fall below. And I'd have to add my standard deviation to my mean to find out this one standard deviation above. So when I do this, I found below by 157 minus 16.2. Sorry, that's a minus there. And I got that to equal 140.8. And then when I looked at above, I found 157 plus 116.2 to equal 173.2. So I'm not done yet though. It asked me how many scores fall within one standard deviation. So I'm going to be looking at the number of scores that fall between 140.8 and 173.2. So let's look at our frequency table. Would 140 fall in that range? No, it's just short. So we need to look at 145. 145 does, 150, 160, and 170 do. 180, that wouldn't. It's above our range. So when I add up this total number of values, I find that 10 out of the 17 scores fall within one standard deviation of the mean. So to answer my question, how many of the scores fall within one standard deviation of the mean? 10 scores. Looking to the future, if I had 10 out of 17 scores, couldn't I say that that's a percentage? Just a little bit of foreshadowing. So, question number 4, our final question. So now I want us to be able to I want us to be able to understand standard deviation in a little bit of a more analytical way. So Tanner and Robbie discovered that the means of their scores for their first semester in math class are identical. So we have the same X bar. They notice, however, that the standard deviation for Tanner scores 20.7, while the standard deviation for Robbie scores 2.7. Which statement must be true? So why don't we go ahead and take a look at each one of these choices. Number 1, in general, Robbie's grades are lower than Tanner's grades. So let's think about this. We're given that they have the same mean grade, but they have different standard deviations. Does that really tell us in general how low or how high Tanner's and Robbie's grades are? No, I don't think so. We don't have enough information to make this accusation for number 1, so I don't think this is true. Number 2, Robbie's grades are more consistent than Tanner's grades. So let's look at what we're given. So we're given the mean, and we're given the standard deviation of each of the students. So let's think about that definition of standard deviation again. Standard deviation measures how far our data deviates or moves away from the mean. So for this example, the larger the standard deviation, the more spread out my data. There's a key word here, consistent. So if Robbie's grades are more consistent, that means that his other grades are going to be nice and tight right around his average grade. Let's look to see if that's supported by the standard deviation. We find that Robbie's standard deviation is a score of 77.2. I misspoke, getting that backwards. 2.7. That's a very small standard deviation. That means that his scores, his average grades, the other grades, are nice and tight right around his mean. They're not very spread out. Compared to Tanner's score, which is 20.7, his scores are really spread out. He probably had some really high grades and some really low grades. So looking at the information that we're given, I think we could make that decision that it's true that Robbie's grades are more consistent than Tanner's grades. Let's just check real quick with number 3 and number 4. Number 3, Robbie had more failing grades during the semester than Tanner did. Is there any information about what a passing and failing grade is in the question? No, I don't think so. So this one obviously couldn't be right. And finally, the median for Robbie's grade is lower than the median for Tanner's grade. So we're given that their means are the same, and we're given the standard deviation for each of the students, but I don't see any given information about the medians. So this information, we don't have enough information to support this answer. So I thank you for going through Unit 12, Day 1, Standard Deviation and Variance. I hope you all have a great day. Bye-bye.